Some steam locomotives were built so well they refused to die. A century later, they are still hauling passengers, pulling freight, or thrilling crowds. These are not museum pieces. They are working machines that have outlasted their designers and the railroads they served. Here are 15 survivors that just won't quit. Number 15, Puffing Billy, 1813. When William Hedley designed this locomotive for Wylam Colliery near Newcastle, he was not trying to make history. He just needed something that could haul coal without breaking the wooden rails. The result was a machine so simple, so robust, that it is still steaming 211 years later. Puffing Billy used a completely mechanical system with no fancy valve gear, just pistons driving wheels through beams. The design was agricultural in its simplicity. 2 vertical cylinders mounted on top of the boiler were connected to the wheels via massive cast iron beams that rocked back and forth like a seesaw. Crews called it the grasshopper engine because of the way those beams moved. It looked ridiculous, but it worked. The locomotive spent decades hauling coal cars before retiring in 1862. Most engines from that era were scrapped immediately. Their metal went into new machines, bridges, or industrial equipment. But someone saw value in preserving this peculiar beast. It ended up in London's Science Museum, where it still runs under steam for special demonstrations. The fact that a machine designed when Napoleon was still alive can fire up and move under its own power is genuinely absurd. Modern engineers examine it and marvel at how little there is to break. Number 14, Locomotion No. 1, 1825. George Stephenson's first locomotive for the Stockton and Darlington Railway was not just a machine. It was a statement that steam could replace horses for public freight transport. On September 27, 1825, this engine pulled 450 people and 90 tons of coal in 38 wagons at speeds up to 15 miles per hour. For 1825, that was practically flying. The locomotive's design borrowed heavily from stationary steam engines. A single vertical cylinder drove the wheels through a complex system of connecting rods. It had no suspension, no springs, just iron wheels on iron rails. Riding behind it felt like being inside a paint shaker. The boiler operated at pressures that seem laughably low today, around 50 pounds per square inch. Modern locomotives run at 10 times that. But Locomotion No. 1 proved steam power could be reliable and economical. It hauled freight on the Stockton and Darlington Railway until 1841, when it was retired after a boiler explosion injured the driver. The railway preserved it as a monument to their founding. In 1975, a working replica was built for the railway's 150th anniversary. The original site's in Darlington's Head of Steam Museum, while the replica still operates occasionally. Both locomotives demonstrate that Stephenson's fundamental design, flawed as it was, contained the seeds of the railway revolution that followed. Number 13, Fairy Queen, built in 1855 by Kitson and Company in Leeds. It was shipped to India to haul passengers on the East Indian Railway. India's climate destroys metal. The heat, humidity, and monsoon rains corrode everything. Most locomotives from this era dissolved into rust decades ago. Fairy Queen survived through luck and constant maintenance. The engine's simple 222 wheel arrangement, 2 driving wheels flanked by smaller carrying wheels, gave it speed on India's relatively flat northern plains. It could hit 40 miles per hour, impressive for the 1850s. The large driving wheels, over 5 feet in diameter, meant fewer wheel rotations per mile and less wear on the mechanism. After retirement from regular service in 1909, the locomotive sat abandoned in a shed for decades. In 1972, railway enthusiasts discovered it and began restoration. By 1997, it was back in steam, certified by Guinness World Records as the oldest working steam locomotive in regular service. Today, Fairy Queen operates luxury heritage tours between Delhi and Alwar, hauling vintage carriages through Rajasthan. Passengers pay premium prices to experience rail travel as it existed in 1855, complete with white glove service and period furnishings. The locomotive runs monthly tours, racking up miles that most centenarians could not dream of walking. Number 12, Copper Knob, 1846. The Furness Railway needed locomotives that could handle the brutal gradients between Barrow and Furness and the iron ore mines in the Lake District. Edward Barry designed this 040 engine with a copper-top dome that gave it the nickname Copper Knob. The distinctive copper dome was not decorative. It served as a steam separator, ensuring only dry steam reached the cylinders. Wet steam causes cylinder damage, something Victorian engineers learned through expensive experience. That copper dome, properly maintained, could last indefinitely. The locomotive's four coupled wheels provided maximum traction for hauling heavy ore trains up steep grades. No fancy valve gear, no complex suspension, just raw pulling power. It ran for the Furness Railway until 1900, surviving 54 years of hard service in one of Britain's toughest railway environments. After retirement, the National Railway Museum preserved it. In 1980, they restored Copper Knob to working order for the Furness Railway's 150th anniversary celebrations. The engine still steams occasionally for special events, demonstrating that Victorian engineering, when properly executed, could produce machines that outlast the companies that built them. The Copper Dome, now 178 years old, still gleams like new. Number 11, Flying Scotsman, 1923. Yes, 1923 is just over 100 years ago, but hear me out. This locomotive did not just survive. It became the most famous steam engine in the world through sheer mechanical stubbornness. Built by the London and Northeastern Railway at Doncaster Works, Flying Scotsman was designed for high-speed passenger service on the East Coast Main Line. The engine's streamlined appearance, powerful three-cylinder design, and ability to reach 100 miles per hour made it a celebrity from day one. In 1928, it became the first locomotive to officially hit 100 miles per hour. That speed record turned it into a national icon. But fame does not pay for maintenance. After British Railways withdrew it from service in 1963, the engine should have been scrapped, like thousands of others. Instead, businessman Alan Pegler bought it and began a mission to keep it running. His efforts nearly bankrupted him. Flying Scotsman toured Australia and America in the 1970s, racked up massive debts, and changed hands multiple times. Each new owner faced the same reality. Maintaining a 100-year-old locomotive costs a fortune. The National Railway Museum acquired it in 2004 and spent £4.2 million on a complete overhaul. Since 2016, Flying Scotsman has been back in regular operation, hauling special excursions across Britain. It is not just running, it is thriving. Number 10. John Bull, 1831. When the Camden and Amboy Railroad imported this British-built locomotive to New Jersey in 1831, American railroading barely existed. John Bull became one of the first successful steam locomotives in the United States, pioneering features that became standard across the industry. The engine arrived with no pilot truck, those small wheels at the front that help guide the locomotive through curves. American track work was terrible compared to British standards, with sharper curves, rougher roadbeds, and less precise alignment. John Bull derailed constantly until Camden and Amboy's master mechanic Isaac Drips added a four-wheel pilot truck. That modification, made without consulting the British builders, solved the problem and became standard on American locomotives for the next century. The locomotive served until 1866, then retired to a shed. In 1876, the Pennsylvania Railroad displayed it at the Centennial Exposition. The Smithsonian acquired it in 1884. But here is where it gets interesting. In 1981, for its 150th anniversary, the Smithsonian restored John Bull to working order. The locomotive made steam and ran under its own power for the first time in 115 years. It still operates occasionally for special demonstrations, making it one of the oldest operable steam locomotives in the Western Hemisphere. Number 9, Lion, 1838. The Liverpool and Manchester Railway ordered this 042-wheel arrangement locomotive from Todd, Kitson and Laird in 1838. It hauled passengers and freight through industrial Lancashire during the height of the Industrial Revolution, surviving 21 years of hard service before retirement in 1859. Most engines from this era ended up as scrap. Lion got lucky. After withdrawal from the railway, a Liverpool dock company bought it as a stationary pumping engine. The railway parts, cylinders, motion, and wheels drove pumping machinery that cleared water from graving docks. It worked in this capacity for another 69 years. Think about that. This locomotive spent longer as a pumping engine than it did pulling trains. In 1928, the Liverpool Engineering Society preserved it. By 1979, Lion was back in steam. The locomotive appeared in the 1953 film The Titfield Thunderbolt, playing itself in a movie about preserving old railways. It still operates occasionally on the Llangollen Railway in Wales, steaming along the same tracks where it once hauled Victorian passengers. The engine's survival through two careers, first as a locomotive and then as stationary machinery, demonstrates the fundamental robustness of early steam technology. When built properly with quality materials and maintained adequately, these machines simply refuse to wear out. Number 8. Southern Railway 1401 Class 1891. Japan's railway system exploded in the late 19th century, importing hundreds of British-built locomotives to handle the traffic. Among them were the 1401 class tank engines, small but powerful machines designed for branch line work. These engines featured a 260-wheel arrangement, with 6 coupled driving wheels that provided excellent traction on Japan's mountainous terrain. The side tanks that held water along the boiler eliminated the need for a separate tender. This compact design let them navigate tight curves and switch tracks in cramped Japanese rail yards. One of these engines, number 1428, survived the modernization purges that scrapped most steam locomotives in the 1970s. It was preserved at the Umakoji Steam Locomotive Museum in Kyoto, where it still operates for special events. The locomotive runs demonstration trips around the museum grounds with machinery that is 133 years old, working as smoothly as the day it left the British factory. Japanese engineers have kept meticulous maintenance records. Every part, every adjustment, every repair is documented with the precision that Japanese industry demands. The result is a locomotive that looks and operates like it is 30 years old, not 130. It is not just preserved. It is actively maintained to working standards that most modern machines do not achieve. Number 7. Beyer-Peacock. 7F 1899. New Zealand's Rimutaka Incline was an engineering nightmare. A 1 in 15 gradient, one of the steepest railway grades in the world at the time. Conventional locomotives couldn't handle it. Enter the Fell Centre rail system and these specialized engines built by Beyer-Peacock in Manchester. These locomotives used horizontal gripping wheels that pressed against a center rail, providing additional traction on the brutal climb. The design was brilliant and terrifying. The engines essentially grabbed the special center rail and hauled themselves up the mountain through pure mechanical determination. One of these engines, H199, worked the Rimutaka Incline for decades until the line closed in 1955. After retirement, it sat deteriorating until preservation efforts began in the 1970s. Today, it is displayed at the Fell Locomotive Museum in Featherston, and remarkably, it still operates under steam for special occasions. The locomotive represents a dead end in railway evolution. The Fell system worked, but was expensive to maintain and limited to specific applications. When the Rimutaka Tunnel opened in 1955, making the incline obsolete, the technology died with it, but H199 survived to tell the story of how Victorian engineers solved impossible problems with mechanical ingenuity that modern computers couldn't improve. Wartime makes strange demands on engineering. The German Class 52, called the Kriegslok, or war locomotive, was designed for mass production during World War II in 1942. It was simplified, brutal, and built to last just long enough to win a war that Germany was losing. Thousands were built. Most died in combat, were scrapped after the war, or simply wore out. But some survived. These engines were overbuilt despite their wartime compromises. The boilers were simple but robust. The motion was basic but reliable. After the war, railways across Eastern Europe kept them running because they had nothing else. One Class 52, number 8055, ended up in Poland and worked commercial freight service until 1988. Then it was preserved and eventually restored to operating condition. Today it hauls heritage trains across Germany, a machine designed for destruction, now providing pleasure trips through the countryside it once helped devastate. The locomotive's survival is darkly ironic. Built to support Nazi Germany's war machine, It outlasted the regime, the war, the Cold War, and the division of Germany itself. It keeps steaming into a future its designers never imagined, carrying tourists instead of military supplies, proving that good engineering transcends the purposes it originally served. Number 5. Pennsylvania Railroad K4s, 1914. The Pennsylvania Railroad's K4s Class Pacific became the most successful steam passenger locomotive in American history. The Pennsylvania Railroad built 425 of them between 1914 and 1928. They hauled every important passenger train the railroad operated from New York to Chicago, from Washington to St. Louis. These were the locomotives that defined American steam power. After dieselization, the Pennsylvania Railroad scrapped almost all of them. 2 survived, numbers 1,361 and 3,750. Both went to museums. But in 1987, number 1,361 returned to steam for excursion service. The locomotive ran special trips across Pennsylvania and neighboring states for decades, thrilling crowds who remembered when trains like this ruled American railroads. The restoration proved these machines were over-engineered even by Pennsylvania Railroad standards. The boiler, built in 1918, passed modern hydrostatic testing with minimal work. The motion, subjected to decades of abuse, needed surprisingly little attention. The locomotive is currently awaiting another major overhaul, but the fact that a machine that is 100 to 10 years old, designed for daily passenger service, can still haul heavy excursion trains demonstrates the fundamental excellence of Pennsylvania Railroad engineering. They did not build locomotives, they built monuments to mechanical perfection. When Union Pacific needed locomotives that could haul 3,600 tons over the Wasatch Mountains without helper engines, they asked Alco to build the impossible. The result was the Big Boy, the largest steam locomotive ever built for regular service. These machines were not just big, they were absurd. Over 130 feet long, weighing 1.2 million pounds, generating 6,000 horsepower. They had 2 sets of driving wheels, essentially 2 locomotives under 1 boiler, articulated to handle curves. Union Pacific built 25 Big Boys between 1941 and 1944. They worked until 1959, when diesels finally replaced them. Most were scrapped. 8 were preserved as static displays. But in 2019, Union Pacific did something remarkable. They restored Big Boy 4014 to operating condition. The project took years and cost millions. Modern welders worked alongside boilermakers who remembered the old techniques. Computer analysis verified structural integrity. The result is a 78-year-old machine that now hauls special excursion trains across the American West, demonstrating that when American industry decided to build something massive and magnificent, they built it to survive multiple lifetimes. Big Boy 4014 is not just running, it is thriving, proving that the age of steam ended only because we chose to end it, not because the technology failed. Number 3, South African Class 25-1953. South Africa's semi-desert interior presented unique challenges for steam locomotives. Water was scarce. Coal was expensive. The answer was condensing locomotives that recycled their own exhaust steam, recovering up to 90% of their water. These machines were engineering marvels and maintenance nightmares. The tenders were massive, packed with cooling fans and radiator elements. The system worked brilliantly when properly maintained, which was rarely the case. Most were converted to conventional operation or scrapped. But some survived, as working examples of a technology that almost succeeded. Today, several Class 25 condensers operate on heritage railways in South Africa. These locomotives, now over 70 years old, still demonstrate their unique capability. On special runs, operators fire up the condensing systems, and the locomotives haul trains across the Karoo Desert while barely using any water. Modern engineers examine them with amazement. The technology could have revolutionized steam operation in arid regions, but by the time these engines were perfected, diesel-electric locomotives had already won. The Class 25 condensers represent the might-have-been of steam technology. They showed what was possible, but arrived too late to matter. Still, They run on, monuments to engineering ambition that refused conventional limitations. Number 2. Norfolk and Western Class J, 1941. The Norfolk and Western Railway believed in steam power when everyone else was switching to diesels. Their Class J streamlined passenger locomotives represented the pinnacle of American steam technology. Built between 1941 and 1950, these engines could reach 110 miles per hour while hauling heavy passenger trains through the Appalachian Mountains. Norfolk and Western designed them to compete directly with diesel-electric locomotives on maintenance costs and reliability, and they succeeded. The Class J locomotives required less maintenance per mile than contemporary diesels and operated more reliably. But the railroad industry was moving on. By 1959, even Norfolk and Western admitted defeat. They dieselized, and the J's were retired. One survived, number 611. After decades as a static display, number 611 returned to steam in 1982 for excursion service. It has since been through multiple restorations, most recently returning to operation in 2015. The locomotive hauls special trains across the eastern United States, demonstrating what American railroading lost when it abandoned steam. At 83 years old, 611 still reaches highway speeds, still climbs mountains, still turns heads wherever it runs. It proves that Norfolk and Western was right about steam power's potential. They just could not fight the inevitable march of progress. Number 1. Durango and Silverton. Narrow gauge railroad K36 class, 1925. These Denver and Rio Grande Western narrow gauge locomotives were built for the Colorado mountains. The brutal terrain, the narrow 3-foot gauge track, and the high altitude demanded specialized machines. The K36 class delivered. Built by Baldwin in 1925, these outside frame Mikados combined power with flexibility, handling tight curves while pulling heavy mineral trains through mountain passes. They worked commercial freight until the 1960s. Then something unexpected happened. Tourism saved them. The Durango and Silverton line became a heritage railway, and the K36 locomotives found new life hauling passengers instead of freight. Today, these engines operate daily during tourist season, not occasional demonstration runs, daily service. They haul full trains, navigate the same treacherous track work, and climb the same grades they conquered a century ago. The railroad maintains them to commercial standards because they are not museum pieces. They are working locomotives earning revenue every single day. The K36s proved that steam power did not fail. We just found better options. But better does not mean best, and these machines demonstrate that properly maintained steam locomotives can run indefinitely. They are still doing the job they were built for after 99 years of hard mountain railroading. And that is all, folks. These 15 locomotives prove that when engineers built machines to last, they really meant forever. If you enjoyed this journey through mechanical immortality, please subscribe for more railway history. Here's another video I have specially selected for you. See you next time.